Okay, so allegedly this should be working. So before we start, are there any questions that you want to go over priority-wise? Yeah. 8 and 11, sure. Okay, so let's just copy down that graph then for number 8. Okay, so for 8, we should have following graph of age, 18 to 18, 19, 20, 21, 22, 23, 24, 25, and then this 32. And then number of people. 14, 120, 200, 290, 30, 10, 2, and 1. Okay. And then we're told that there are, where am I? Well, we don't know how many people there are, right? So how many people are in this stats class? This is a huge stats class, right? How many people is this? That's 14, 120, 200, 200, 90, 30, 10, 10. Yeah, 667. So if you want to find the median, since that's an odd number, the median is going to be, let's see, 667 divided by 2. So the median is the 334th age from the bottom. Okay, so that shouldn't be really a concern right now. Does everyone get that, right? So where would the 334th be? So if we look at a cumulative distribution, cumulative frequency. So 18, cumulative frequency is at 14. 19, cumulative distribution is 134. 20, cumulative distribution is 334. Okay. So where is that 334th person? Well, they would be 20. Right here, right? That would be the median person right in that. Right there. Yeah.
Alexander, please meet your mother in the front of the school. Alexander Nicolis, meet mom in front of the school.
So embarrassing. So sorry, Alexander.
Would there ever be a time where the median is in between 3 ranges?
Yeah, that is a possibility.
So what would you pick at that point?
Well, let's just say that there are 668. Then there's a good chance that median would be somewhere between the 20th and the 21st. So then you would pick 20.5.
20.5.
Yeah, 20.5. If it's an odd number, you divide by 2 and round up. If it's an even number, you divide by 2, and then that number and the next number averaged.
So it's all between 2 and then you
Does that all make sense or no? Was there anything else that you want to prioritize? 11? And you could, except for there are 667 numbers that you have to put in. I don't think you want to do it. You'd have to put in 14 18s, 120 19s, 220s. So, you know, if you have a strong enough calculator, you could. Okay, so that was, you said 11, right? 11. Okay, so we might as well do 11 and 12 at the same time. So, how do I change the default font? Anyone know? Options? Ah, yes. Trebuchet. You know, my favorite font is Trebuchet, just because, you know what a Trebuchet is? It's a catapult. It's a catapult. Yeah, it was a catapult.
We had a whole discussion about the difference.
Yeah, Trebuchet. It might be a French catapult. That was it. Can anyone take French? What's Trebuchet? What is that? What is a trebuchet? There you go. Siege. Yeah. So when you have a castle under siege, you use the trebuchets to break down the walls. You have a picture? And then there's a wiki how to build one. Man, I wish I could not have to focus on. Anyways, let's do this. I'm sorry. Number 10, number 11. We have 20 employees, so the box plot of salaries looks like this. Let's just draw it. So we got it's really selling it for you, right? Okay, so why aren't you? Okay, so 11. So that's what the box plot looks like, and I think one thing that maybe we don't talk about too much is If you notice the box plot is divided into 4 distinct parts, right? There's where is now that I've reset my thing, I don't know where all the defaults are anymore. So sorry about this. It's kind of necessary though. You want to see pointer? Yeah, use pen as pointer. There it is. Wait, where'd it go? There we go. Okay. Yes. Okay. We have 4 parts here. 2, 3. The 4 different parts of the box plot. And what is important to know about that, or one thing that you should know, is that each one of those 4 parts represents 25% of the sample. So if our sample in this case is 20 employees, this tail right here, the upper tail, represents 5 employees. This box over here, that is 5 employees. Okay. So if we take a look at 11, I don't know if this will bear out with anything, but it says the maximum salary is between 6,000 and 7,000. I don't think that's true. It looks like the max box plot is around 80,000, isn't it? Restart required. That's about 30 right there. It's about 40, 50, 60. 70, 80. So it looks like the max is somewhere around here, right? 77 or something. So I think A is probably false. The minimum salary is about 20,000. Well, the minimum salary is down here at around 30,000. So that's false too. Interquartile range is 20,000. Well, let's see. This is about 60,000. This is about 40,000. So IQR. Disappearing one, yeah. So IQR should be about 60 minus 40. Yeah, that's about 20,000. How about the median salary? The median salary is right here, right around 50,000. So I don't think the median salary is actually 40,000. So the one that is true looks like to be letter C. How do I change mode? Darn it. Oh, that's good. I like that. So sorry I have to set this up over again. Okay, so Definitely. So it looks like C is correct. No. IQR is equals Q3 minus Q1. So in our case, that's 60,000 minus 40,000. So in our case, the IQR is about 20,000. Okay. 12. Based on the box plots, would you say that this is fairly symmetric? Yeah, I think the distance here between the median and the maximum is about the same as the median and the minimum. Maybe a little bit longer, but probably not long enough to say that there's a lot of skew. Next. About 10 employees make more than 50,000. Well, here's 50,000, and that's the box and the upper whisker. We just said that each one is about 5, right? This is 5 people here, 5 people here. So yeah, about 10 people make more than 50,000. That's true as well. Nobody makes more than 80,000. Yeah, that's true. Here's 80,000 here. There's definitely no part of the box plot above it. So I think the correct answer here would be D, all of the above. Yeah.
So is it true for every box plot that each part represents 25%?
Yes, every box plot. Each part's 25%.
And they're all in that format. So.
Yeah. All right, so that's 10 and 11 and 12. Actually, we might as well do 13 too, right? 13 would have been nice if we just did that first. Anyways, the minimum is about 30. Q1 looked like it was about 39 to me. The median looks right at 50, maybe 49. Q3 looks like about 60, and the maximum looks like about maybe 77. Again, those are all estimates. If this were actually a multiple choice test, you would pick the number set which is most similar to this. Okay, that's 13. Anything else you want to prioritize, Tiff? Yeah. There are 4 parts. 13 is asking for the 5-number summary, which is a little different than asking for the box plots.
If 13 wasn't multiple choice, would you be wrong if you put 30,000 instead of 30?
Well, these are in thousands, right? So somehow you'd have to communicate that that's 30,000 and not actually 30. Awesome.
You go with
15, sure. So 15, we have more box plots, and we want to know which of the following is not correct. So 50% of the male students have a weight between 150 and 185. So 150 and 185 looks to be the interquartile range. Q1 looks like it's about 150. Q3 looks like it's about 185 for the males. And if we remember, that would be the first box, the lower box, and the upper box. Each of those boxes are about 25% of all the male students. So that's true. 25% of the students have a weight more than 130 pounds. Yeah. The upper tail for the female students starts at around 130 and ends at around 154. So that would be about 25% of the female students. The upper whisker is 25%. The median weight of the males is 162. Certainly the line in the middle of the two boxes is right around 162. That's true also. The mean weight of the female students is about 120 because of symmetry. And that one you got to think what's really being asked here. And I know it says mean, but they really mean median because of symmetry. Mean and median are about the same. If in a symmetric distribution. Mean is approximately equal to the median. Do you see approximately equal? I don't either. How about here? Do you see approximately equal? Do you see it? Approximately equal? I can't. Yeah, I know I could, but I'm trying to set this up for the rest of my year. Help me out. Yeah, yell if you see it, okay? Ah, there it is. So the mean is approximately equal to the median. In a symmetric distribution, the mean and the median are approximately the same thing. So if the median is 120, then the mean is also about 120 for the females. Which brings us to the last one, is the males have less variability than the females. Not true. The male boxes seem a lot bigger than the female boxes, which mean the males have more IQR. Male IQR is greater than female IQR. IQR is a measure of variability. Have more. That's what that would be. Yeah. Sure. Let's look at 10. And for 10, well, the big trick for number 10 is that you can't actually calculate the average average salary for all the workers, simply because in order to figure out the average, you're going to need to know how many male workers there are and how many female workers there are. But what you can know is that if you averaged all of them together, the average shouldn't be smaller than 35,000. Because if you add the male workers in there, then their average is higher than 35,000, and that's going to drag the average actually higher, closer to 35,000, or closer to 41,000. So if there are more males than females, the average of all the workers is going to be closer to 41,000, but not over 41,000. If there are more female workers, the average is going to be closer to 38,000, but not lower than 38,000. And of course, if you have an equal number of females and males, then the average is going to be right in the middle between 35,000 and 41,000, which is what, 37,000? No, it's 38,000. 38,000. Yeah. So actually, we don't know what the median salary is. It just can be any number between. It has to be a number between 35 and 41,000. We don't know actually where it is. 10. Since we don't know, yeah, it's between that 35, 41,000. How's that spelling for you? Or rockers, brokers. That's 10. Okay. Yeah.
Can you do 14, please?
14. Sure. 14 says that a sample of 5 recent births gave.
Oh, wait,
Yeah, gave it. Well, might as well do 14. We're gonna have to do it eventually. So the average is going to be just all of those added together, which is what, 89, 122, 137, 144, 98. And we're going to divide it by how many of them there are. I think there were 5 of them. And that gives us an average of 118. That's our average weight. Assuming I didn't do anything wrong. Never quite sure about that. Yeah, absolutely. Seven. Okay, so for 7, actually, you should be doing this on your calculator, right? And so let's start off by putting those 4 numbers into the calculator. List 1 is certainly an appropriate place to put it.
So we don't have to know how to do it by hand.
You should know how to, but you never have to actually do it.
And even on the effort too.
Let's put all the rental values. And then you're going to use one var stats. That should calculate your standard deviation for you. Remember, you're going to use S instead of sigma. Sigma, not sigma x. You see sigma in there? Darn it. Where's my Greek? It's not Greek. Getting there. What? You see sigma? There it is. Okay. That should take care of 7. Anything else you want to go over? Let's look at 1 then. All right, so 1, we have more frequencies divided by where the median is, and there are 100 students. So 100 students divided by 2 is equal to 50. The median is the average of the 50th and 51st student. Okay, so where is the 50th student? So maybe we should look at cumulative frequency. We got grade and cumulative freak. So 91 through 100, 81 through 90. 71 through 80, 61 through 70. Cumulative frequency here is 16. 16 plus 42 is 58. 58 plus 31 is 91. So the 50th and 50th first person, that would be right here. So which interval would contain the median?
71.
Yeah. We don't know exactly where, but we know somewhere between 71 and 80. Yeah.
So the empirical rule, it's used in single peak symmetric distribution.
Yes.
Is there
Exclusively.
Exclusively. Are there any other phrases that would apply other
Approximately normal. Normal. That would be it. 2 and 3 we did in class, so I think we're going to skip those. 4, did we do 4 in class? Yeah, we did, right? First quartile Q1. And IQR range, we did that as well, right? So 4 and 5 we did in class. Oh, we did 6 in class too, right? 7 we just did. 8 we did, right? 9 we definitely did in class. We just did 10. We've done them all? Yeah, we have done them all. Okay. Anything else you want to go over?
For box plots?
Yeah.
You said we could put the specific numbers rather than
Yeah. So what would be okay for me with a box plot? This is okay. Okay, so let's get a box plot here. Here's the box plot, right? Let's get an outlier 2. This would be fine for me. 30, 35, 38, 42, 45. Hey, erase. It's not erasing.
Go the other way. Verticals.
Vertical doesn't work. This is not good. So, and let's just say this outlier is 68. Okay. That would certainly be okay with me.
You want us to put the IQR or the distance between the outlier and
Well, yeah, it should be proportional. Everything should be proportional still.
Can we label as well?
Not necessary. I think whoever, I mean, if you're drawing a box plot, you should already know what all 5 of those represent.
Don't label the axis.
There's nothing to label. You could, I mean, alternatively, you could also just put a number line and then float the box plot over the number line. That's fine too. If you float the box plot over the number line, you don't have to label each individual part. Shannon? That's an outlier. No. It's actually important that you know. Every outliers are they shouldn't be a part of every distribution. When you see an outlier, that means something strange happened. You don't know what, but something strange happened.
So then you don't include it when you're doing like the median.
No, you still include it, yeah. For the median, you still use it.
What constitutes an outlier?
Remember, an outlier is greater than Q3 plus 1.5 IQR,
Okay.
or smaller than Q1 minus 1.5 IQR.
So 1.5 IQR is
That's our standard
for outliers.
for outliers, yeah. Yeah.
Okay, and then so what we're working with, we're either using the empirical rule or Chebyshev rule.
Yes.
And then unless it says single peak symmetric, approximately normal or normal, that's only empirical. If it doesn't say anything, then we need to.
Chebyshev.
Okay.
Yeah. Let's write that down. Normal, approximately normal, single peak, and symmetric. And there was one more, unimodal. I can't spell. They all mean use empirical rule. Everything else is Chebyshev. Yeah. Hmm? On a box plot, positively, well, let's look at this box plot right here. Okay. Notice that distance there versus this distance. Which one's longer? The right side. Right skew. The other way around would be left skew or negative skew. Including the outlier. Yeah.
So then you have parallel box plots like in FFP1 part A.
Yeah.
In FFP1 part A, it has been taken from 1988, and when you put in the calculator, 1987 is at top, plus 1, and 1988 is at the bottom. Do you want us to label that if we were to draw?
Absolutely.
So how would we label it?
Just on this next to the box plot, like right here. Just write like 1980.
Okay.
Yeah, just on the side.
Chebyshev rule, when we have the 100, that equation, that's used to determine the standard deviation.
That's used to determine what proportion or what percentage of the observed values are within K standard deviations. Remember, the way that Chevy Chev's inequality works is you'll get a number out of it. So let's say if we use 2, I think you get 75 from Chevy Chev's rule. So Chevy Chev's rule says that 75% or more of the observations are within 2 standard deviations.
And then if we memorize the rule that it goes by, we don't really need to know the.
Well, there are funky things that could happen, like use Chevy Chev's inequality for 2.2 standard deviations. So you would still need to memorize the equation.
Where would we plug in 2.2?
K. The only thing you're ever going to plug into Chevy Chev's rule is K.
And then that would go in the solver?
No, you can just evaluate that in the calculator. 100 times 1 minus 1 over 2.2K, 2.2 squared.
Okay. And then will that give us the percentage?
That'll give you, a whole number percentage.
Okay, so, but if will we ever get a decimal? Oh no, we're multiplying by 100.
Yeah. You shouldn't get a decimal. Well, I guess you could get a decimal, but it's customary to round.
So is it also like 68% or more, or did it?
No, empirical rule is exactly 68%. Well, no, I shouldn't say exactly. I should say approximately 68%, but not 68% or more, just approximately 68. That's why the empirical rule is a little bit more exact than Chevy Chev's rule. Exactly. Do you have any other questions? Okay, I'm going to stop recording then.